Okay, by my watch, it's time to begin. Can I get someone to close the doors? Just to cut down on the noise. Remind people that we have remote participants, and so please use the microphone. This is the note well. It was updated for the meeting this week. Yet it's Friday. You've probably seen it a whole bunch of times, but still, we must follow it. So please pay attention. At the SEC dispatch meeting earlier this week, two drafts were discussed, and the recommendation of the SEC dispatch working group was to send them here. So the first one has to do with short-lived certificates, and the second one has to do with using hash-based signatures in the cryptographic message syntax. So these both are clearly out of charter. So it's interesting that we have a new way of getting suggestions that impose a recharter. So I'm not going to use anything during this meeting to start discussing charter text, but in the next week or so, we'll start a discussion to tackle that action. So this is the agenda. It's been out for quite a while. If there's any bash, please do so now. Okay, so the first two items, are you bashing, Alexi?
No.
Oh, okay. I just wanted to, all right. So the first two items have to do with including internationalized email addresses in certificates. One is an update to 5280, which essentially updates some of the internationalization things, and the second one defines an other name to carry the EAI. Those are now both finally in the RC editor's queue. Alexi has something to say.
Correction, the second one is not.
Oh,
You need to send
thought
it.
was.
It's still,
No, I thought he had. I
checked the data tracker status. It doesn't say.
Right now.
All right.
Okay, in a minute, it will be.
Well, I could, but some people might think it's.
Okay, I'll figure it out.
Okay, thank you.
I mean, as far as I know, we're doing this as mechanics, not like.
Yeah.
Something.
I'm just checking.
I could swear I saw email that it was done, but okay.
I'm pulling it up right now. I mean, you drop it like that.
I believe that the area director believes all of the open issues have been sorted. That's for sure the email I saw. Anyway, the next one is two documents that have been sent to the ISG. They together define SYM 4.0, and we have some issues and that were raised, and Jim is going to address those. There it is.
Okay, so I've been, due to workload, sitting on a couple of comments from the AD director that when I look, the AD, sure, the AD director, that basically when I looked at them, I said, oh, I'm not really too sure what the right answer for them. This isn't just an easy edit. So next slide. So the first one is he requested a simplification of the language. This is basically the traditional language that Russ wrote way, way back when, and everybody's just cut and pasted it since then. And as Ecker pointed out, it is redundant as all get out.
Indeed.
So are there any issues with actually just cleaning the redundancies up that anyone has?
Are you,
Basically what I'm
does the
looking
red
at,
and green text,
basically what I'm looking at is anything that's green goes away.
anything,
Green.
black stays too, right?
Black stays too.
Okay.
Anything that's green goes away. That means that black and red stay.
That is not how I would have done that. Okay.
So as one of the people who,
Well, the way I highlighted it was anything that's red actually was important.
Hi, Sean Turner. So as one of the guys who probably copied this forward, let's just fix it and be done with it.
I'm assuming that there is absolutely zero interest in making any sort of errata changes. Good.
Is it just redundant or is it incorrect?
It is redundant.
Then, so far.
Okay, next slide. This one's a little bit more complicated. Part of that language basically said, if things aren't right, what do you do? It just says, don't do it. So basically, you've got a whole slew of things that might actually occur and be wrong, but we don't give any guidance on what you should be doing. We just, right, so far I've basically said, no one does it, we can ignore that problem. So when any of those things happens, we've got a couple of different things we can do, and they may differ based upon which violation it is. One thing would be to say, just ignore the attribute entirely. One would be to come up with a canonicalized method of choosing which one you want to use. And one would be kind of a mixture of, if it's something you care about, then you need to make an error out of it. Otherwise, you can just let it slide. So choosing which one is first and using that one is interesting, because it basically, the thing could occur multiple times, and with each occurrence there could be multiple values. So choosing which one's first would be like kind of saying, let's collect all of them together, sort them and by lexicographical order, and then take the first one.
This is Russ Housley. Given that this has been in SMIME 1, SMIME 2, SMIME 3, SMIME 3.1, SMIME 3.2, and we have not had any interoperability over this, the senders are following the musts.
Either
Not.
that or the recipients
Or-
aren't noticing it.
Right. So what I would propose is that we put a statement in that if any of those musts are violated, the recipient should ignore it. Not must, but should, and then that will at least make things okay.
Are you would that be happiness, Ecker?
So I think for the last two, that's fine. For the first, I mean, the first two are the same, right?
Right.
But it seems like it should be an error if it's signed, don't you think? If it's not signed, don't you think?
It should be ignored.
You think so?
That's what we call it.
Okay, I mean, it's a working group decision. Well, not what I would have done.
I mean, this is information about what my
Stefan,
case. So sorry, Stefan Santos, 3XA Security. So I mean, S-MAN capabilities is advertisement of my capabilities.
Correct.
So if I stated something that violates not being once, I mean, I still stated it. So there's no harm in assuming that I can deliver on that statement. So I don't know why you should say should ignore.
No, the real issue is if you provide two statements of your capabilities that are not the same, what do?
Add them up.
The other thing is there is more than just this one attribute that has the problem.
Correct.
There are other attributes that have the same problem. For example, hash.
Or signing time.
Yeah.
Yeah.
I mean,
I mean,
could
hash is the
there
worst
could there
one.
be I mean, could there be conflict? One says something that is completely incompatible with another. I can
Sure.
see that. Okay, then there is a bigger problem.
Right.
Paul Hoffman, who actually only came here for CAA, but for history value. Well, the other problem we had was signed and the signature has to be valid. So when we came up, well, but this was one of the reasons why we sort of left it at just be ignored is if the signature is broken on that, we don't want to say, therefore, everything goes to hell. We just want to say, okay, ignore it. Or at least that was the thought 10 or 15 years ago.
I mean, right. This is a deliberate thing on the point of the sender. This is not an attack in the middle. Probably.
I mean,
Since-
no. I mean, maybe. Consider. Consider the following situation. We have a pair of client and server, sender and receiver, where they've been using RSA 1024, and they both grow their capability to do code 25509, and the sender sends you a message with SMI capabilities is a signed message, and SMI capabilities that are that say I can do 25509. And now I got to think about the order of the signatures, but the bottom line is that the guy in the middle strips out the signature, thus causing you to receive the message, but ignore the not limited capability that's downgrading you. So again, I got to think about the order of like which pieces are protected by which other pieces. But like the fact that like the fact that this is sort of a bundle of things, it's not clear to me exactly like, it's not clear to me that like that treating non-signedness as ignore is equivalent to like not having any attacks, right?
Well, by doing that, he's also stripped the signature off the content. It's the same signature.
Yeah.
Yeah.
That's probably true. I mean,
Yeah.
I just think I'm not sure I have a real thing. I'm just sort of saying like it's not obvious to me that it. I mean, certainly it's just not obvious to me that ignoring under these circumstances can have any security implications. But again,
So-
like this is a working with decisions. I'm not like saying you shouldn't do it. I mean, I'm saying like personally, like I'm surprised people think it's a good idea. But like as area director, like this is like you guys think it's the right thing to do, then like I'll step out of the way.
John Levine. I don't purport to be an expert in this area, but I can say in every other place where we've tried to guess how people screwed up and recover from it, it has not turned out well. We're telling people how to interoperate. So like if you want it to work, do this. And if you don't, and if you do something else, you're taking your chances. So I think ignore is probably the simplest advice. The alternative is to continue not to give any advice because
That's right.
if you don't do it, then you're not interoperating. So you're outside the bounds of what we're describing.
Okay. So
I guess we do have to decide whether ignore and go ahead and accept what's there in some form or pretend the attribute didn't exist.
That sounds like we're getting into local policy.
Well, I was going to propose was reject the message with an error. Yes. So certainly we can give other advice than ignore. Is reject the message with an error because it's malformed,
or reject that particular
I mean,
signature.
I'm going to say draft Thompson Pastel is wrong here. I mean, like again, like there are multiple options. I just want to hear what the options on the table are. Like, is it, if people comply, I mean, I guess I would claim if people comply with this now, then reject with an error is harmless and will improve the ecosystem better.
Eric, let's say we went down that path. Would you be happy with a should reject or must reject?
I think, yeah.
Okay. Does anyone in the room want to speak against should reject? Okay, then you got.
Paul Hoffman, I would like to speak against should reject just because of history. That hasn't been being rejected till now. I certainly would assume that, the folks who are doing S-MINE capable clients will do this, and all of a sudden a message that worked yesterday will not work today because it should reject is going to be, that means default reject. And I don't think we have a good reason why. So somebody, especially where if the signature was getting munged in, by some gateway, especially on the sender side, the recipient didn't really care about the signature and such like that. It's just always been sort of going through.
I don't think that's right, Paul.
Okay.
I think what's happening is all the must and must nots imposed on the sender are being followed. This is never happening.
Oh.
Yeah.
Okay.
We're silent on the
Yeah.
recipient behavior when they're not followed. And that's what we're trying to fix.
Okay, I can believe that. Yeah, and at which point then, yes, it would be logical to say that. I was always thinking on the recipient side. Okay, I can believe that.
Okay, so I think at this point, that's clear what we should be doing. Next. Back one. There's some language about weak cryptography, which is left over basically from the days of 40-bit stuff. And since we've now basically moved triple DES into the world of we think that that's too weak to be used, language saying that weak cryptography basically gives you no benefit is a bit more sketchy than it used to be. So should we clean this language up, or do we just leave the language as is? And the first sentence is basically what's in the document.
Yeah, I mean, my claim is the first sentence is just false. I mean,
Yeah, I think that's probably a correct statement.
so I mean, I think you do need to replace this saying that is like more nuanced than law security. But like, I think a lot of things you could say, but I mean, 3DES is like, as far as we know, very nearly as secure as AES 128. So,
yeah, I mean, Phil Hambaker, the issue is weak being used as a term, weak cryptography being used as a term of art here, or just a descriptive term? Because if AES is strong, well, it's not weak. So, I mean, but you could just fix it by saying, instead of having offers, replace it with small, lowercase may offer. So it says using weak cryptography in S-MINE may offer little actual security over sending plain text. And then we're done.
Racking through my brain, I believe it is not a statement of art. It is just a descriptive statement at the point.
Okay, so
Okay.
Okay.
no, unfortunately,
Yeah, I bet that's something I have to actually double check on.
I'm trying to find it.
I assume it's in the security considerations.
So the section in 272 says about choosing weak cryptography. All algorithms that use 112-bit keys are considered by many to be weak.
Yes, that's a term of art.
That would be a term of art, yes.
So, and also, I mean, actually, it's weird. It says this says,
Use the mic, please.
sorry. So now that I actually noticed this, I see it also says all algorithms that use 112-bit keys, not 112-bit keys or less. So apparently RC2 is not weak cryptography. So like this is like super weak, mega weak. I don't know. Strongly weak. Yeah, there you go. Exactly. Yeah.
It's a strong key in a weak algorithm, right?
I mean, look, I think it's fine to call it weak. I'm not objecting to calling it weak. I mean, do we have? I mean, and I'm trying to remember. Is like RC2 and DES like even in this document anymore at all? Are they
Only for historic purposes.
Yeah.
But I mean, but like my point is, this document does the term of weak in this document need to cover them as well? Because if it does, then we need to revise 272, so it covers them. And then I think maybe I can set some new text here. I mean, you can basically just say like I mean, I guess really we can nuance this like with another sentence or two.
My memory is that what it says is you may have things in your folders that were
no.
encrypted. And
This
used
is
to say
basic.
that.
Where this text is, if I remember right, is where this text is first used is you may need to send to somebody who's got an old client, and that may not be a good idea.
I see. Both are true.
I mean, it's for the historic one, you kind of have to support it if you want to read your old mail.
So this sentence is in security considerations.
Okay.
This quote.
Good.
This is Daniel Kahn Gilmore. So, I mean, while my inner pedant agrees with everyone that this text is false, like it seems to me like the security considerations goal here should be to give concrete and opinionated guidance on what people should be doing. And I don't actually think it's that big of a deal to have an overstatement here. So I would say leave it alone.
Well, 112 or less, I think should be fixed.
Yeah. Yeah, weak is not necessarily tied to key size.
Yeah, I guess. I don't think RFC should say things we know to be untrue. I mean, no to be untrue. Like, we'll say lots of things are untrue that we don't. Well, we should not knowingly put things in RFCs we know to be untrue, because like both of those clauses can be violated. I think Phil's suggestion will be fine. Does not meet modern security standards and may offer a little security over plain text. I think like a number of things you find here. I just think it shouldn't like actually be false. That's all.
Okay, I think I know roughly the sort of thing it needs to say, so I can probably manage a rewrite at this point in time. Next slide. PKCS6 certificates. Yes, they are still in the spec. Yes, it says you're supposed to be able to accept messages that have them. I don't know why, although my code does do so, and then promptly ignores them. Is there any problems with just making this an absolute must not?
Does anyone support PKCS6 anymore?
Has anyone ever supported PKCS6?
I mean, some like BDC probably did.
Yeah.
TTF probably did actually.
Seeing no one trying to defend it, I think we go with must not.
Okay. The second one is I basically need a historical dredge because my mind has failed.
Oh yeah, so I remember what's going on here. So.
We actually have a question from the, the question, this is from Sean Leonard. He wants to know if it's in the ASN.1.
It is in the ASN.1.
So I'm trying to figure out a copy of like where I'm doing this, which is not being in hand, but I push back on this, and I remember why, which is to say that the time this test about being a trusted agent, right?
Okay.
So, right. So, I mean, the problem is if you have, let us say you have a situation where you determine a trusted agent by doing PKI verification from some root, right? And so, like, I don't know, the agent's got the name timestamp.sign.com and you do PKI resolution. So you receive the message and it's got a signing time sometime like relatively far in the past. And so you evaluate the certificate chain on the basis of that time, which is from the trusted agent. But in the meantime, the certificate's been revoked. And so, but that means you can't trust that. The sign time is in there. So I just don't understand how this text provides the security it's supposed to provide. Because you need to know the time of day when the thing was generated in order to evaluate the certificate chain, and in order to determine the trusted agent, in order to determine when you can trust the time.
Right. No, I completely agree with you. I mean, it's that the text as written makes absolutely no sense. What I was trying to dig out of my brain and have been unable to do so is what sort of trusted agent we thought we were talking about in this situation.
Oh,
That I can't help you with.
no, that I recall was the timestamp authorities.
That was my guess,
Yeah.
but I couldn't remember for sure. In which case, the way this sentence is written makes no sense.
It's still wrong, but
At that point, you may use a counter signature to establish a time to verify this
would be
signature.
far better.
Yes.
Stefan?
I just wonder if it's a must not on the sender or receiver side, or both.
This is during validation. It says so.
Receiver.
This is
So
receiver.
if I encounter one, I must reject.
The text that I cut it before this basically said you should use the current time when doing validation.
Oh, sorry.
And then
I
this is the qualifier on the should.
Yeah, I was actually sorry. I was actually asking the PKC 6.
The PKCS 6 says.
I was a little bit slow.
That's a different certificate format.
Yeah, no.
Non-X509.
It basically says you should accept it, but you don't have to process it.
Because it's a clear a must not on the sender side, but is it a must not on the receiving side? No.
I should hope not, in case somebody has one stored in a folder.
Exactly. So it would be an incompatible change.
Yeah.
Backwards.
Okay. So I think it may still be worthwhile to talk about using using a time from a counter signature to validate, but I think obviously this text as written is totally bogus. So okay, I can do that. I think that's the end.
It's your last slide.
Okay, that's it. So I should have changes to Ecker to approve by the end of next week. And once once he says those are fine, I'll republish and send to the list so that the list can actually look at everything I've changed. And then we can go to IESG last call.
Okay.
Okay, so the next agenda topic is regarding CCA simplification. And I think Jacob's going to present remotely.
CAA.
Isn't that what I said?
No.
I'm sorry.
I
what
and DCAA too.
That's what I meant to say.
Yes.
Hi, everyone. Can you hear me all right?
Yes.
Yes.
Great. So in case you hadn't heard, CAA is a great success. It's mandatory for CAs in the Web PKI now, as of last September. Along the way, we proposed and approved in this working group an erratum to how CAA records are discovered, in particular, how they handle C names and D names. So as implemented in the Web PKI, when there's a C name chain, you just evaluate it straight through, and you don't go into each host name in the CAA chain and do additional tree climbing on that. So our main goal with the current draft is to bring in that erratum and document what's implemented in the Web PKI. The current draft also has a deployment considerations section, which describes some of the practical failure modes we've seen from some DNS servers in the wild. So that's pretty far along. It's been adopted as a working group draft. So the next step for me is to upload the next revision of it as a working group document. There are also 2 open pieces of feedback. Corey Bonnell of TrustWave has a fix to the AB and F grammar of CAA records, which is ambiguous in 6844. We also have a request for a section describing what changed and why, which I'll add in the next draft. And that's all I've got.
Any questions? People are coming to the mic, Jacob.
Great, thanks, I can see him.
Yeah, Jacob, Tim Halbeek. There's also another errata that Corey has open about the issue of when there's a CAA tag and there's no issue record in that. Everybody on the list is clear what the correct interpretation is. A strict reading of the existing document, though, does not actually say that. So that's another one that I think you're going to want to fix.
Yep, thanks for the reminder. I've added that to my to-do list.
Paul Hoffman. So I've been touristing on some of the various cab forum lists where this sort of blew up, some months ago. I don't think we're that close to done necessarily until we see the working group document, simply because some of those things that you've documented in the, strangenesses we found out there, the people who reported them when they said we did something really meant it as we did it in good faith. So I think that there's going to need to be more text in the body that says explicitly don't do this for a fairly large number of thises, at least 4 or 5, even though those of us who are used to reading protocol documents, thought that. I was surprised by the number of different implementation errors that were there. And again, done in good faith, not out of laziness. These aren't like, IoT OEMs. These are CAs who really care about being a CA next year. And so I think it would be really good to lengthen the document a little bit with, even though it seems like if it says do X, if someone did the inverse of X, for whatever reason, I think it's reasonable to also say must not do inverse of X as well, based on the implementation experience.
That's great feedback. Off the top of my head, I'm not sure of the exact examples you're thinking of, but if you could send some examples to the list, that would be super helpful. Thank you.
Tony Finch, I have had a look at the current draft, and I noticed that in the deployment considerations section, it talks about dropped answers and refused answers. One of the problems that we encountered when CAA was introduced was the problems with issuing certificates for private domain names. My understanding is that CAs have altered their code to make it more lenient in the kind of problem cases that we encountered. But I wondered if that's something that should be described in more detail in the draft. And the other problem that we encountered was to do with CNAME handling, but it looks like you're already addressing that, so that's good.
It's a good question. I think the experience that Let's Encrypt has had is that there are kind of 2 common mechanisms for having a private sub-branch of your main public domain space. And one of them works fine, where your public name server returns that next domain. And the other doesn't, which is, I believe, the one where you delegate to a non-responsive name server for subdomain trees. But that definitely merits some discussion in the deployment considerations.
Any other questions? Okay, we look forward to the, I'm sorry.
Yeah, this is from the Jabber Room. It's Corey Bonnell. Has there been any discussion on changing the should for querying the authoritative name servers to a must in section 6.3?
Not as far as I've seen. So that sounds like something we should discuss.
I guess if he wants that change, bring it to the list.
Sounds good.
Okay, I'm not seeing anything else. Thanks, Jacob.
Thanks all.
The next topic is Shake for PKIX and then CMS.
I don't know if Panos is here.
He's not in the room.
So last time we received comments from the group and to make changes and to remove the DSA, and we also added a lot more details to it. Next slide, please. So we removed DSA, we updated the OIDs, we added the mass generation function, we updated the RSA PSS section. We added the public key OIDs, updated in introduction and INA sections, updated titles and some other things. So here's all the Shake's OIDs again, number 17 and 18, and the function OIDs has the parameter. It's called Shake output length, which must be accommodated with the OIDs whenever one of these functions is used. And for this document, we require the output length to be greater than or equal 32 or 64 bytes. And here's, we copied the OID for the mass generate function number 1 from the BKCS number 1. It's right now number is 8. To use the Shake as the mass generation function, the OID must accommodate must have the parameter which is a hash algorithm value, and so in this case you have to use either one of those two OIDs we mentioned above. So here we copied again from the RFC 4055. In this document we require the either one of those two functions to be used at the hash algorithm, and the Shake output length, which is accommodating the Shake OIDs, must be present and either equal to 32 or 64, depends on which Shake is used. And here we specify the length, the Shake output length for each of those use cases. So this length basically just to make sure that the Shake function is executed only once, and that would be enough outputs for the mass value. So that is the efficient of the Shake to be used at the mass generation function. For the sort length, we just propose to make it easy by specify either 32 or 64 bytes. Depends on which Shake is used.
I can't remember, but does 4055 impose that salt not be 0?
We not right now. We have not said anything or proposed anything about how the sort should be.
The last bullet says you did.
Yes, right now we just say the length, but we should have been more specific about how how set should have been generated as well. And right now,
No, I'm asking explicitly about the salt length. I haven't looked in a while, but I think 4055 allowed a salt length of 0.
I think the standard, the current standard, doesn't say any restriction about the salt length, as far as I know. But it's just a new thing to make sure the security should be properly handled.
So the salt length in 4055, this is Sean Turner, the default is 20.
20. I see.
20 that was used for SHA-1.
Thank you. Yeah.
It's in one, so it doesn't matter.
No,
Yeah.
but thank you for the memory.
I think the intent for 20 was the standard was developed during using SHA-1 at the time.
Mhm.
For what it's worth, in TLS, we're requiring salt greater than or equal to, and the signature we're requiring greater than or equal to the natural digest length.
Okay. That makes sense now that I think.
Of course, we don't place any requirements on what has to appear in the subject public key info.
Right.
It would sure be nice to not have this syntax, but I guess we're kind of stuck with it
Yeah,
now.
we're kind of stuck.
This is just like a mess.
Mhm. It is more complicated than I would like. But this is imported from PKCS1.
No, I recognize that.
Okay.
Yeah, I mean, at some level, like I would actually prefer just define, ID, RSA, SSA, PSS, Shake 256.
Mm-hmm.
And actually, I guess so. It's worth considering whether we should just do that. I mean, it's not actually particularly helpful to as a consumer of this technology, it's not actually helpful to have to parse the PSSA and then parse this crap. And given that we're now basically defining, new algorithms, I don't know. Sleevy may have a different opinion. I mean, this is a shit show, right? So I don't know how to get out of it. But I can't decide. I keep hoping that maybe eventually we'll just only have the ones that are. If we start doing good ones, we'll only have the ones that are good. But maybe that's just totally hopeless.
Ryan Sleevy. Yeah, so I agree with Ecker. We've had a lot of talk from an implementer side for RSA, SSA, PSS, and the notion of having our ID, RSA, SSA, PSS. Shake 128 is certainly preferable. The idea of the variable complexity, even with this of configuring the salt len for Shake and then throw this in, is not something from an implementer and from an ecosystem standpoint that we'd be terribly thrilled with, at least on the public PKI. I don't know if there's a use case for this flexibility in the private side.
So Sean Turner again, it's actually worse because of the way the syntax is set up as default. So you can't ever not include those things so that it's bigger.
Right.
It's always going to be bigger. So
correct.
I guess I wouldn't be I'd be happy with doing just an OA that did everything.
Yeah, Martin Thompson, +1. I've had to review code that implemented PSS. I didn't write it, and I'm glad that I didn't have to, because it's awful. And it's, as Ryan said, it's full of landmines, interoperability disaster, basically. So let's just make a new void. It's easier.
This is from Sean Leonard. He asks if should the Shake output length requirement be expressed in ASN.1 as a size constraint, and similarly for RSA, SSA, PSS param salt length to restrict size to 32 or 64 accordingly.
Jim's going to answer that. He's shaking his head.
I'm actually going to get up here and say, yeah, I think actually just changing to a new OID is actually a good idea. The flexibility here was actually so that you could have different mass generation functions, and you could use different hash algorithms in all three locations. And we immediately followed that up with the advice which says, use the same hash algorithm in all three places because that's the only way we know it's secure. So there's a whole lot of flexibility here that we can just eliminate. No one that we've ever run across is using a different mass generation function, and the hash functions are always going to be the same. So there's no particular reason to give us the flexibility for that. Relative to using the constraint, yeah, it's not written in to begin with to let you use the constraint. Adding that information is just going to be a pain.
So I'm hearing is you're happy with defining the hash, the math generation, using the same shake function. And also defining the salt length to be fixed like this would be fine as well.
No, what we're,
Yes.
yes, but I mean, we're advocating defining an OID that only has one value for each of these parameters. I mean,
You don't even need
that is associated with one value for each of these parameters, and therefore the salt length would be exactly one value. I mean, and yes, the parameters you have selected are the right parameters, but what we're suggesting is like having an OID which just nails them down.
I think what he's suggesting, Quinn, is that the first line change to ID RSA PSS shake 128, and then say, when you use that, it means, and say all the things, then define the same thing, shake 256, and say, when you use that, it means all these things. So you get two OIDs, no parameters.
Yeah, Ryan's like plus one to that is that all of the parameters are fully expressed within the OID.
Correct.
Every time we've seen a permutation of parameters as applied to both TLS and the PKI, it becomes an interoperability mismatch both on policy and implementation. So one OID that expresses everything you want to configure plus one.
All right.
One more question from Sean Leonard. He's asking for clarification, which component or components enforce the size constraint, because it won't be the ASN.1 encoder decoder.
Yeah.
Right. There won't be any parameters, so that won't apply.
Okay. I'm pulling out of memory, so I actually would need to go back and double check this.
Yeah.
But in point of fact, if I remember correctly, the salt length is actually is there as an imposition from the public key to the signature algorithm, and the actual value, the verifier does not actually use that value. So you don't care what the salt length is when you verify the signature, because you don't know what the salt is anyway. But I have to go back and double check that, but I think that's correct.
I mean, it is in.
I can't believe we created a parameter that the recipient doesn't need. That doesn't feel right.
It is.
Well, you don't have the salt.
I mean, so if I'm reading this text correctly, from the third full graph of 5.2 describes, like, tells you there's a salt length parameter and tells you have to check that it's greater than or equal. I suppose it's possible it's not passed into the signature computation function, but I'd be surprised.
It has in the computation function, not the validation.
Sorry, in the validation function. Really?
I don't think so. That doesn't feel right.
I mean, I have to go not to go read it. Remember how how PSS works. But that doesn't. I mean, I thought PSS was like done like a la the official way to do PKCS1, where you forward generated the block and then just compare it, right?
Yeah.
So then you must need the salt. You must need the salt length, because like you're not doing. It's like there's nowhere else for the salt to go, right?
I think it sets the line between the two. That funky little Feistel network thing it sets up.
So Martin Thompson, I think from memory, you need it, but you need it because it might be greater than the length in the SPKI. So I think that's
okay. But we're going to nail it down by
just
defining an OID and say
put on it and
right.
Yeah.
Okay, Quinn, is the direction clear?
Yes.
Okay.
So I just copied the the OIDs for public keys over here from the RFC 4055.
No.
Oh no, I'm sorry.
No, that's the new slide.
You're gonna need new ones.
No, this is the public key identifiers. A copy from RFC 3279 and 4050.
Right, but you're gonna need new OIDs for the public keys when the PSS public keys, right?
Correct.
Okay.
I mean, by the way, these, like, just to be clear, it's like PSS public, this whole like PSS only like keys is like itself a menace, but like But like, I mean, if you're going to do it, you should do it. You should do it this way, right?
Okay, so could we do it as a no?
I mean, you're going to need, you're going to need two new ones that you use both in the signature and the public key. And I'm assuming that you continue to operate the situation that a public key, which has RSA, which has RSA encryption, is valid for any combination of PSS parameters, right?
No.
So
Any new PSA algorithm.
yeah. So basically, that you can use an RSA encryption key to sign with RSA PSS, whether expressed with the old parameter syntax or the new OIT syntax.
Okay.
I mean, this is making it much more like elliptic curve algorithms as far as the key thing is met.
All right. Next slide. Yeah, and we added security consideration section, and it's copied most of the text from the previous RFC, and we just describe about the chase function as an addition information to the section, which are fundamentally saying they are deterministic functions. So when you don't generate multiple outputs from the same input multiple times.
Okay.
I have one question for the chair and for the group. Should we say something about how the sort should be generated in the documents? Because right now we're not saying how the sort is supposed to be generated at all. We just say sort. So either sort should be generated from some random source with a good hash or pseudo random function, or the sort could be generated from a random pseudo random value and a private key. So in case if the random source is lousy, bad, the private key could give the additional security benefit to it. For example, like running the shake over the sort concatenated with the private key. So basically, the sort would be like a randomized value for the private key as the key generation secret.
Why would you put that guidance in this document?
I don't know. I'm asking if
you should not put that guidance in this document.
Yeah, I think if it goes anywhere, it goes in PKCS1.
Yeah, and in point of fact, what PKCS1 says is the randomness is not critical to security.
Fitting.
The sorts got to be unique, and if you how you made it unique?
No.
No, it doesn't.
The next sentence is you can use a fixed string.
Yes.
That is in the paper or in the standard?
In PKCS1.
The RFC says, in situations where random generation is not possible, a fixed value or a sequence number could be employed instead, with the resulting provable security similar to that of FDH.
Okay, so I take that as a face value.
I don't know. I haven't read that. I haven't read that paper in like a really long time, if ever. I'm just telling you what it says.
Okay.
I mean, clearly, if a counter is okay, then it doesn't. That it's not important to have the thing seeded with like a strong key.
Exactly.
All right. So the CMS documents, it has similar RSA and ECDSA sections from the previous documents. In this section, there is the KMAC, which is used to replace the HMAC for CMS.
So I'm not sure it's worth going through the details of these slides because I think what the advice of the group will be, once you change the OIDs in the PKIX document, change this one to follow.
Correct. And could we go straight to the KMAC section?
Sure.
here. So basically, KMAC is what we using from the NIST SP 800-185, and we follow that, and we make a fixed length for the output size, either 126 bits for the shake 128 or 512 bits for shake 256 to make it simple. And so I don't know if the group would like some flexibility for the output length, or the group would be happy with the fixed length like been proposed right now.
If it would require a parameter.
No. Okay, so fixing everything would reduce parameters or remove them all.
No, my understanding is you would need a parameter for the length.
Yeah, currently right now the hash function, we made the fix. We don't need. The thing is, the employing the hash function requires the parameter. But if we could change the OIDs for the hash function without parameter, that would be possible. However, that would make a little more complication in the mass generation function, because the mass generation function, the output length for the hash in the mass generation function is different from the output length when the hash is used in hashing messages.
I'm not following.
So for hashing right now, for example, shake 128, when you use the shake as a hash function, the output length right now been fixed to 56 bits.
Yes.
But when we use the hash in the mass generation function, then the length is going to be equal the size of the modulus minus the hash values length and minus 1. That is the length for the shake 128 when it is used in the mass generation function, to avoid repeating execution of the shake itself multiple times.
Okay, I thought you were talking about the encoding, but maybe I'm misunderstanding something.
I was.
You were, okay, yeah.
So right now, as you define the shake 128 and shake 256, whenever the OID for either one of those is used, the parameter output length must be accommodated along with it. Because there are two situations at least for different lengths. The first one is the 256 bits, for example, shake 128, when using as a hash function, and the output length is the modulus size minus the hash value minus 1 when shake 128 is used in the mass generation function.
But you never have to represent that in OID, because the OID the MGF doesn't have to be, you mean MGF for RSA, right?
Yeah.
But you never have to represent that. You never have to represent that OID on the wire, because you just the only OID you represent is the one we just agreed on, the ID RSA blah 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 shit,
Yeah,
blah blah.
we could do that. We could do that.
But I mean, then you don't.
But I'm saying when people okay, when we when you pause the mass generation function, oh, you're going to make that fix too. Okay.
Yeah, basically
Okay.
like the
fix everything. Okay.
you fix everything, right? So like there'll be a lookup table which tell you what to do, right? Based on
Okay.
so then you just need seems to me you need 3 separate OIDs. You need one OID for like SHA-3 for 3 separate groups of OIDs. One OID for SHA-3 as a digest function. One OID for RSA with like each variant of SHA-3, and one OID for shake, and one OID for each variant, for each shake variant with each variant of SHA-3. So you'll need what? I guess you have two sizes of SHA-3, so you need 6 OIDs, as far as I can make out.
I think 2 of them are already assigned, but
quite possibly, yeah.
Okay.
No, but would you be okay with the the OIDs of the hash functions have the output length parameter?
I think they shouldn't. Like, why would I? Why, like, they have native sizes, right? If you want to, I mean, that seems like
use use the other hash function. Use the other shakeoids, the one that nails down the output. There are those already assigned.
No,
Just
but
use them.
that would have some problem we need to solve in the mass generation function, because in the mass generation function we want the output length to be a lot longer than 256.
but that parameter is never represented on the wire.
Right.
But how? Okay, so we just
The parameters represented on the wire are one hash function for when you need to do, like, I guess for when you need to put it at the front of like a CMS message, right? Two, the type of the RSA key, which is associated with, which now we've agreed is associated with all the SHA-3 values. Huh? No, I'm just talking like all the possible ways with like the union of these specs, and as far as I can tell, 6 weights. One, the bare hash, one, the combination of RSA with each hash, and 3, the shake combination with each hash, which ought to have a fixed output size, which is the natural size of the digest.
Right.
So in all and you never need to represent, and when shake, I agree, shake is used as an MGF, but you don't need that. That doesn't need to represent on the wire because that's implicit in the OID assignment between RSA and SHA-3.
I know, but for the current specification of the BKCS standard, the mass generation takes 2 parameters. One is the source and the output length.
Yep.
I understand, but we're just going to write that down in the
You're going to
document.
say when you use this away, those values are.
So, okay, so basically, so the shape function will be used differently from the normal hash function.
Correct.
Yeah.
Well, it'd be encoded differently.
You're right.
Be used the same way, I imagine.
All right.
Do you know what to do?
I think so.
Okay.
But yeah, I'm still not pussy about the length output in the mass generation function now. But it's okay. I go with that.
Okay. You can bring it to the list if you get confused.
Yeah, we'll do. So what is next slide?
That's it.
Yeah, next slide is asking for comments, questions.
I think you got lots. Okay.
Okay. Thank you
you.
for the attention and the comments, and we improve the documents one more time.
Philip's up next.
So we had a little incident. So I first got interested in this when, well, basically the incident happened like this. An affiliate to one CA decided to change to being an affiliate to another CA. And so as part of that switchover, they said to their first CA, we would like you to revoke all your certificates because we've just reissued them for the other CA. Okay, now first CA said, no, we want to keep those certificates because you are not the subscriber and therefore you don't have the right to revoke. So affiliate then sent an email containing a list of 15,000 private keys for said certificates, saying, okay, now they have been compromised, revoke, which CA did. So there are 2 separate questions that interested me here. One of them is, well, shouldn't we have a better way of proving compromise of a certificate, of a private key rather, other than actually posting the private key itself? And
a signature is adequate.
Right. So basically,
you make your own signature.
yeah.
Service. Yeah.
So basically a standard for a suicide note. And I asked Russ, and Russ contributed the first 5 bullets here, and then the Acme folks said, well, we also have a revocation message. So that's one issue. Jim is about to tell me another one.
Yeah, I'm about to tell you another one. CRL that lists yourself.
Yes, that's now that is actually my preferred one. Would be to simply have a CRL signed by the certificate itself, because that's one that is probably the easiest to create with existing toolkits. So, I mean, like, one possible work item for the group is, okay, we've got 6 possibilities here, and Jim's just added a 7th. We should have one. Well, we'll need to have one if we're going to expect anybody to do it. So that's one area. The other area, which is more kind of like a research item that I think people need to pay attention to, is why did that affiliate have access to 15,000 private keys? And this kind of like had me really puzzled until I started to think about what that affiliate was doing. In that what they were doing was essentially they were a technology provider to a web hosting provider, and they were almost certainly managing the whole crypto interface for the web hosting provider, if not more. And that is a very common thing in our industry now, in that you have technology providers who are managing multiple web hosts on a cloud infrastructure. And what they will be doing is pulling a host from here and moving it to there and moving it from here. And when you think about the management that those people need, of course, the certificates, the private keys are going to end up in some database somewhere. And so that's a point of vulnerability I think that we need to be aware of and start to think of ways of maybe avoiding the need, providing the ability to manage all those cloud services without having such an enormous single point of failure.
Yeah, Tim Halbeek. There are a bunch of other. This is a very hard incident to discuss because of the fact that there are a bunch of really interesting things that happened, and it's not a particularly. One probably wants to base one's best practices off of hypothetical occurrences in which people are actually interested in following best practices, right? One of the other ways that these people one of the other reasons that they likely had the keys around was because in this particular person was generating the keys as well. And one can hypothesize that many of the keys were stored just because they were generating them and they didn't necessarily have a need for them and just happened to be storing them. And if you look at some of the practices that existed around this incident as well, including, cross-site scripting vulnerabilities that allow you to get root on the host, even if you did have a best practice for demonstrating revocation, I think there's very good evidence that we still probably would have received a zip file full of private keys. I had to spend an entire afternoon writing a best practices document. There's lots of things around these providers and things like that that probably could be improved. It would be great. I agree. We really should have a discussion about what our best practices around revocation requests, because everybody's doing it differently. And a lot of the methods do not have particularly great properties. And I agree that disclosing a private key for the purpose of proving that you have possession of it is perhaps something we should ban, right? Which is slightly different from awesome, which I heard right next to me from somebody who probably would be willing to say that in public.
I don't really want to focus on that particular case.
Yeah, that's actually the direction I was going.
Yeah.
I think discussing that particular case that's just a nest of zaniness. So we should think about your case is actually much more interesting. Cloud providers that have a legitimate need for having these keys and things like that.
Well, at the end of the day, I have a large number of websites at a large number of accounts, only some of which which would be associated with me. And, I used to keep tabs on my competitors. I don't know why I'm doing it now. A lot of the time, you can just say, I want SSL on this website by clicking a button, which means that that key is being generated for the subscriber, which, and then it kind of like whizzes around this data center. So
yeah, and if you're doing that, I mean, the other thing, and it's not so much an IETF issue, but if you're doing that, you should have to publicly disclose that you're doing that.
Yeah.
Paul Hoffman, so I don't think that this is a good forum for figuring out best practices and policy. Giving people a way to do something, especially if it's just one way, I think is certainly appropriate. But going back to the very beginning of what you said, this sub-CA, I call them, had a legitimate desire. They ended up, and they were told no, and so they ended up sort of forcing it. But I think that a thing that we could consider as well is, if you have a legitimate desire to do a mass revocation or whatever, will that fit into one of the ways we're doing it here? That is, should we then say, as Jim would say, create 20,000 CRLs, one for each one? Should there be a way of doing mass things for the exact reason that you brought up at the very end, which is, in fact, there are 1 million private keys that are not held by the people who own the websites. And there is often very legitimate business reasons for moving from one CA to another. Especially the CA might tell you, oh, I'm sorry, we've changed our name, we've changed this, you have to do this. So I think that this should be in scope for as we're figuring out the methods. It might be just suck it up, I don't care how many you have, create that many CRLs or that many revocation requests or whatever. But I think that should be part of the use case.
Yeah, I mean, I don't have a solution yet. I'm not sure that I will have a solution, but I thought that I should raise it so that then we can start thinking about it. And it may be that in the medium term, we end up wanting to change TLS and other things in order to facilitate. I mean, short-lived certificates might be part of the mix here.
So, I mean, if you do want to have a suicide note, one important property that said suicide note ought to be that it can be generated immediately upon receiving the key and is not to be timely. Because one situation is I have a key on my machine and the machine's stolen, and now I can't generate verification. So I haven't thought about how Acme's request works, but I imagine like all other Acme requests, it has some sort of anti-replay mechanism. And in this case, you don't want an anti-replay mechanism. That's undesirable because so yeah, I mean, you want to be able to pre-generate it.
Alex, you're next.
Thank you, Russ. I'm here to introduce a potential draft that we have posted about 2 weeks ago. It has to do with allowing X59 certificates to contain multiple public keys and multiple issuer signatures. Next slide, please. Now, the motivation for this was we were looking at all the migration that we're going to have to do when the post-quantum algorithms become available. And if you think about key establishment, I mean, that's negotiated between two peers, and it's a little easier to update in phases. But when you think about authentication, then we depend on the certificate chain that is issued by a PKI that only has a single algorithm in it, and we can't really migrate unless we duplicate infrastructure, duplicate certificate chains. So what we were trying to do is create a certificate that would have both algorithms, and then the application can choose one versus the other. Next slide, please. So what this draft describes is a hybrid certificate of sorts. We place alternate public key and signature inside the non-critical extensions so that existing clients can process these certificates and ignore those extensions. Now, if that certificate is processed by an upgraded system, then it could ignore the classic signature and go to the quantum safe one. And so essentially the way it's done is by layering signatures, we take all the certificate attributes, including the quantum safe public key, we sign it using a quantum safe private key of the issuer, and then we place that signature inside the non-critical extension as well, and then we sign it using a classic key. Now, this type of certificate is a little larger than the ones we have right now, but at the same time, classic systems can process it without failing. So we've done a number of independent experiments between the 3 companies that worked on this format, and we have posted the draft describing in detail enrollment, revocation, everything on it. So if you have any questions, please ask them now or post them on the mailing list.
Have you looked into the IPR issues? Because Certicom used to have a patent on this.
We will be looking at that.
Yeah, I mean, it may be expired or expiring, but it's a nice hurdle to beat.
Paul Hoffman, we may be heading towards a world where there are multiple post-quantum algorithms that are chosen. Some would, one that a world that I've heard of is an algorithm with small keys, large signatures, and another one where it is large keys, smaller signatures. And what I didn't see in your document was a way of multi-signing the multiples. Is that something that you're intending to do, or you're assuming that the CA is going to have picked one for creating the certificate?
So the motivation for this was migration so that legacy systems can process these certs.
Yep.
So that is why we only had one algorithm added.
Mm-hmm.
Now, nothing prevents us from adding multiple sets of those extensions or creating a hybrid signature of sorts where the OID describes multiple signatures and then the signature is a concatenation of multiple signatures. So that could be
I certainly hope those worlds don't appear and that we get one. But from the tussle that we are hearing, those of us following the NIST list, I believe that we will be worse off than just SHA-2 and SHA-3. I think there's a reasonable chance that NIST or whomever, or NIST plus whomever, is going to end up that we might have 3 or 4 to pick from.
Right.
Yeah. So okay, great. Just as long as that's something in your mind, because I didn't see it in the current one, of that you can't assume that everyone's going to pick one post-quantum.
Right, I agree, and this is something again we considered, and we're interested in hearing, feedback from everyone to see which way is better. Is it better to create a hybrid signature OID and then just put all in one extension, or have multiple sets of extensions?
Right.
I think multiple sets of extensions will complicate the format a little bit.
You're talking about a PKIC certificate already. You missed complex by over 20 years,
So these are going to be quite large, right?
Well, depending on the quantum safe.
I'm
algorithm.
assuming you're using hash signatures, right?
Well,
and that seems the most likely.
Well, we've tried with LMS and Dilithium, and then Sphinx is in the works to try it out.
Right. So I mean, we're talking about something that's in the order of several thousand octets, right?
Yes, sure.
So that's going to make people fairly sad. Yeah, right. So I mean, the thing is that, so I'm going to suggest something that I'm not sure I'm like very much either, but I mean, certificates like this will be almost unusable in any web context because it'll be too large, right? And no one's gonna take 2 more MSSs to deliver the certificate. So generally there's a problem in any interactive context. So the one thing you might imagine doing is actually omitting the signature, omitting the post-quantum signature, replacing it with essentially a digest of the post-quantum signature, and treating that as a promise, and then delivering this to the authenticating party separately. And so the way this would work would be the authenticating party would get 2 things. It would effectively get a certificate, that was essentially a classical certificate with effectively a promise for the post quantum signature and potentially a promise for the post quantum key too. And then it would get a separate object, which and then when the client and then it's like in TLS, the client would say, "Look, I want post quantum," and then you deliver the cert and you deliver the things that fulfill the promise separately. And so that way, not everybody else in the world has to absorb like the extra. I mean, if you want to get rid of incremental deployment, like basically no server is going to accept like having that big certificate expansion. But if you're talking about like certificate expansion of like 70 bytes, that's a totally different story, and people might take that. So I don't know, like I haven't thought about it really clearly. So maybe you don't care in interactive context, but
it would also support caching if you already had it.
Yeah. Okay. Again, I'm just sort of vamping at the mic here, so like maybe it's a terrible idea, but I can tell you it's a real problem for certificate size is a real problem.
Thank you. And the main motivation for this was migration to post-quantum, but the way it is designed, I mean, it's algorithm agnostic, right?
So we kind of had this problem when we addressed logos, right?
The logos were bad.
Right. You had something big and you didn't want to shove it in there, so you put it somewhere else. Put a pointer to it in the certificate, and then put a hash of the thing that was over there, so no one could play cut and paste attack.
Okay, thank you.
Yeah, so Ryan Sleevey, I just want to give a +1 to Edgar's suggestion. When we look from a browser perspective at the real world deployment of OCSP stapling, for example, this is actually one of the concerns that comes up. The size of the OCSP response being delivered in the handshake, the fact that you're delivering it to clients that may already have the OCSP handshake, so the caching matter that Tim mentioned. So putting it in the certificate and the fact that you need to deliver this to down level clients becomes a problem. So in looking at what this looks like, the idea of a negotiation to opt into this, whether like at the TLS level, et cetera, Echo's solution I think is probably cleaner because it is within that bound of overhead that you could probably just send it anyways. But for something, if you do go down this route, then it's more than likely going to be that you have multiple certificates. You have the down level certificate that does not have any of your post quantum, precisely because you need to support clients who simply do not care about that, the same way that you need to support clients that don't care about OCSP stapling, and you don't want to shove an OCSP response to them if they're not going to use it.
Thank you.
Hi, Sean Turner. I mean, this also brings up the thing that we talked a little bit about earlier with the supported stuff for SMIME, the SMIME capabilities. You got the old and the new, and which one do you do? And if one doesn't work, do you take the new one? And that's a policy thing, and we don't know what to say about that. And we've tried that a couple times in the IETF, and we pretty much fall on our face. So I'll be curious to see if you put two or more in, right? Then you figure out like which one's good, and I don't know. And I think this is like the third algorithm that's post-quantum safe. So we have to decide which one is post-quantum safe. And I don't know, that gets to be kind of challenging. So I guess I just think there's lots of dragons in this space. And I still think that having two certificates just makes everything a whole lot easier. A pointer to the other promise essentially seems to make much more sense than trying to put two keys in or two other sets of signature values. Just,
That was a technical comment.
Yeah, this is Sean Leonard again with actually a similar comment. He says digesting a pointer subject information access like a URI.
Okay, thank you.
Martin Thompson, my initial reaction was the same as Sean's. But just thinking through Echo's suggesting a little bit more, I think that perhaps we're going to need to talk to the TLS working group for this one. That's unfortunate, but they're kind of busy right now.
Less busy.
But the less busy very soon, yeah. But the key point here is that if you are going to make a promise, you then have to define a mechanism by which you fulfill that promise.
Extensions, my friend.
Extensions might not work in this case.
What?
Because there's some uncertainty as to whether or not you're going to get something that needs fulfillment.
So I actually was thinking about this precisely in the context of TLS. And so bear in mind, so I'm assuming that you would offer two extensions. One extension would be the signature algorithms, which said like which would only have the post-quantum algorithms, and the second would be a placeholder extension, which would allow the server to send you in the certificate entry the things that fulfill the promises.
Now you just paid the cost, but yeah.
No.
Oh,
And the server will be smart about it. You expect the server to be smart about it and only send it if it had the thing in it. Yeah.
So the experiment we did with TLS is what we did. In TLS 1.2, we modified the NSS, and we configured the Apache to have this certificate with 2 signatures. So then it would enable 2 types of cipher suites with 2 different signatures. So then, depending on the client, if you only understand the CDSA, that would be negotiated, or if you understand post-quantum, and then the server would just send the same chain, but then sign the Diff-Hellman key using a different private key.
And that technically works fine, but the consequence is that you've made the server's first flight much bigger, and like we get a lot of trouble to keep the server's first flight within the initial sea wind. And so if you make the thing much bigger, you get out of sea wind, and that makes everybody really sad. So like I mean, it's like pretty important to keep these certificates small. Again, it doesn't matter. I mean, for CMS maybe it doesn't matter, but or maybe it does. But I mean, for any interactive protocol that has congestion control as part of the handshake, it's critically important to keep the server small. And they're already too big. Yeah.
One of the things I'm slightly worried about, if you do the indirect step, is it'd be if you have a TLS URL to go get your external key, and you need a external key to get that one, you may just kind of turtle yourself down.
That's why I was assuming not a URL. I was assuming common handshake.
This is Sean again. He wants to know what the implications are of having multiple public keys with the same certificate subject name and the certificate serial number.
He knows.
Well, the whole idea would be the same identity with the same subject name, same serial. It just has 2 different, keys that it could use to sign digest.
Yeah. So Martin Thompson, how would you imagine this being used in a context like TLS? Would you get both signatures over the handshake, or would you just pick one? Or, I mean, are we going to identify this by saying I want the XMSS signature over the handshake? Wow, that'd be fun, wouldn't it? Or I'm willing to take the combination of that and something else. There's a bit of a combinatorial explosion there that goes on that we have to think about a little bit. Right. Just something to think about, because in general, the idea is great, but the details are nasty.
Thank you. And just to comment on the multiple certificate chain idea, I mean, yes, I mean, there's one way to go, but if you think about large enterprise, then you have to let user or the application select which credential to use, where, if you bring it all the way down to the protocol level, it's a little simpler in terms of support and management.
It's a trade-off, right? It might be simpler for the user. I always pick the one and only credential I have, but now the complexity moves to the protocol.
I mean, so like most of the protocols already do have mechanisms for selecting sort of different certificate chains, so you can support, for instance, RSA, NECDSA, or ECDSA and E25519. So I think, like, this does seem clever, but it's not entirely clear to me that it's better than having multiple chains. And it certainly has, it requires to invent some new mechanisms. We don't have the kind of blow it's talking about. So, I mean, I guess, it's not, I mean, conventionally, my thing, I mean, so like, it seems like that in some cases we're having hybrids. And so, like, as you obviously talked about that, and like, I can imagine, like, so one thing I imagine to be a very sensible hybrid would be a, post-quantum key establishment algorithm signed with a classical signature algorithm. That's an extremely sensible hybrid, right? Because you say like, look, I don't trust, like, I don't trust classical key exchange against future, like, compromise. But like, I trust, but as far as I know, there's no quantum cryptographic attacks and signatures. And if there were, like, I would just cut over then. But like, it's not clear to me what this does, because basically it's either, I mean, you actually have 2 parallel infrastructures, one for the post quantum and one for the classical. It's not like, it doesn't make any sense to like take the use the post-quantum signature to verify the classical signature algorithm. That doesn't do any good, right? So you have to essentially have two silos. So I'm not clear to me why merging them is sensible, but I guess I got a little carried away trying to actually design and user constraints. So
Thank you. So the last of the agenda item is just a heads up. And we have 1 minute left, so it seems to fit. Draft Housley CMS mixed with PSK is a technique for adding a pre-shared key to an existing Diffie-Hellman or RSA key setup so that you are able to provide some protection against the invention of a post-quantum, a large-scale quantum computer. If you have a pairwise pre-shared key, this technique, I think, doesn't make a lot of sense because you should just use that and use the CMS encrypted data technique, for example. But if you have a key that you've distributed to a group and then mix it with the other technique, the creation of the large-scale quantum computer will expand the scope of people who can deal with the back traffic to those who have that pre-shared key. So all this is a call for please take a look, since the CMS experts are the people here. I appreciate the review. This is the end of the IETF for this time, or IETF 101, I should say. Safe journey home, and thanks for your attention.
2 minutes ahead of the meeting.
2 minutes. How close are we?
Yes. Discussion on list with Quinn makes it clear I need to say more in that
I mean, keep it small, right? Yeah, that's what I'm saying. I'm wording to be the impression. That tells you how. Yeah. Great.
Yep.
So currently,
Yeah, don't. That's right. You say I use the algorithm.
Yes. That's still not. It is the relay fixed like that. Yeah. And would not follow. I haven't been with that. So that was actually because you have to specify.